All right. Thank you for joining me, everyone. My name is Jeremy Fairbank, also known as El Papapoyo on Twitter and J Fairbank on GitHub. And today we're going to look at Redux, kind of a high-level overview of a lot of its features and how it really works, and just how we can do different things with it for managing our state. So, very briefly about me, I work for TestDouble as a remote software developer and consultant. And we believe that software is broken, and we are here to fix it. So our mission is primarily to help improve how the world builds software. And we do that by not only working alongside your team and just getting stuff done, but also helping them improve and grow as a team through their processes and other facets. So if you're interested in learning more about how we can help your team improve, or if you're looking to join an awesome team of developers and consultants, please say hi at testdouble.com. So state management in the front end has been sort of like the Wild West for several years. And there have been a lot of options for how we manage state, change it, where we store it, and they've just not really been great at scaling and making our applications maintainable. One of the earliest methods has been just storing our data directly in the DOM. We can store it, we can pull it out, we can mutate it, and this approach does work for just small one-off apps, but when it starts to grow like large-scale applications, you end up with jQuery spaghetti-like code, and it just gets harder to maintain because we have this separation of concerns that we're not worried about. We're just storing state in our view layer as well, so it's really problematic. Then we started applying MVC to our front-end applications, and I'm not going to knock on MVC per se. I still think it's a very good pattern, but it can suffer from some of the same problems where we can end up with state spread out across our application. In this case, we'll have multiple models. And once our applications start to get larger, it can get a little harder to think about where's all my state at, where's it changing. And on top of that, you have controllers and views, and they can all kind of mutate and change state as they see fit. So it adds some organization, but it can suffer also from not knowing where our state is and how it's changing at a high level over our application. So moving on from that, we also applied this two-way data binding, which become really popular with frameworks like Knockout and Angular 1. And it was a pretty good pattern as well, but it can suffer from some of the same problems as applications grow and grow. We have state spread out, it's bound to all these view models, but when I change state in one model, sometimes that can cascade over to some other place that I never expected. Worse, you could even end up with cycles where you just have infinite loops of state changes when you bring in events. So again, it suffers from some of these same scaling issues, and it just becomes harder to maintain and reason about how is state working in my application. So really, the main problem we've been suffering is that state is just everywhere, and anyone can change it as they see fit. So it's hard for these applications to really be predictable at scale and for us to understand and maintain it. So this is where Redux comes into play. And Redux hopefully is a way of organizing our state and making it a lot more manageable. So it's a way where we can consolidate state in one place and change it in one place. Now Redux is actually a very tiny library, and we'll see here in a few moments, we're going to actually build our own ad hoc Redux, and we'll see how very little actually can go into it. Now Redux is typically associated with React, but it can actually be used independent of React. So you can use it with vanilla JavaScript, you can use it with other frameworks like Angular or Vue. And then it builds itself as a predictable state container. That's a really loaded term, so let's start diving into it and kind of unpacking what does that even mean. So we'll start with this idea of a state container. And really all that means is that state is in one place. It's wrapping over your state. And the idea is we want to consolidate state in one location so that we know it is no longer spread out over our application. We can open up a Redux app and we can quickly know where's my state, what does it look like. I don't have to worry about it being across the DOM or across models. And so it makes it easier for us to reason about and understand what's going on with our state. Now that predictable part, it's kind of self-evident, but just to make sure we're really understanding what that means is state changes in one place as well. So it's consolidated in one place, it changes in one place, and that's something we call the reducer, and we'll learn more about that in a bit. Second, this state will change in well-defined ways. That's something we'll also learn about called actions. And then finally, these changes are serialized. So instead of the view layer, or controller, or whoever just mutating state as they please, they all are going to have to go through one place, one at a time, to change state in well-defined ways. We can no longer mutate it as we see fit. And the idea is we no longer have surprises and our applications can be a lot more predictable. So the overall architecture of Redux is a little like this. We have 4 pieces, and one is actually not Redux proper. But we start off with just our state, and that's whatever application state we need to represent our app. That could be a shopping cart, it could be a to-do list, so it's objects, arrays, whatever you need to represent your state. Now the view layer, this is the part that's really not Redux. This is sort of bring your own view layer to Redux. So this could be React, it could be Angular, Vue, it could be vanilla JavaScript. But that state is going to be fed in via API calls that are available on Redux's library. And you can grab the state, and then your responsibility is to use the view to display that state. You're not going to mix the concerns of managing the state on your own. That's Redux's responsibility. You just need to display it for your users. Now your view layer can dispatch events, or what we call actions. And the idea is when we want to change that state, we have the well-defined ways of doing that. These are called actions. Your view layer will dispatch those so that you can handle them to actually update your state. And so that is going to go into the reducer. So when a view layer dispatches one of these actions, it'll come up to the reducer. It'll also receive your current state. And then the reducer's responsibility is to essentially interpret that action along with the current state and return a new state. Because we don't want to mutate the state. We want this to all be predictable. And mutations can happen unbeknownst to us and make our applications harder to trust. But to really get a grasp on what these concepts mean, let's not actually look at Redux itself. Let's just apply its principles first and just kind of build our own ad hoc Redux to understand what it's really accomplishing for us. So I have a very simple application here. It's just a counter app. We have a number, and we have an increment button and a decrement button. If you click on the increment button, it goes up by 1, decrement, it goes down by 1. Very basic hello world type application. And that's all the HTML we need to deal with. Now if we wanted to implement this with just some vanilla JavaScript, we could try something like this. We add some event listeners for the increment button and for the decrement button. And then we're just going to mutate the DOM. We're using it as our state storage, and we're just mutating as we see fit. Those are the 2 things that we don't really want to do. And so we're going to slowly refactor this and bring in Redux principles to organize how state is changing. So the first thing we can do to fix this is get rid of this issue with separation of concerns not being adhered to, and let's pull the state out of the DOM. We don't want to store it in the DOM anymore, because right now it's just in a text node. So now we're going to update it, and we're just going to pull the state out to a global variable. Not the best yet, but at least now the state isn't in the DOM. Now when we dispatch an event, when we click on the increment button or the decrement button, we'll mutate that state directly. We're still mutating the state, as you can see, which again isn't ideal, but we're working toward fixing that. The idea is now we've separated out state from the DOM. And then once we change the state, we'll create a simple render function, and that's what's responsible for taking the state and rendering it out for us. But now let's work on this other issue. Anyone can access and mutate that state. As long as they have a reference to that variable, they can increment it, decrement it, or change it to a string even if they wanted to. So let's apply Redux principles to this. I've talked about it a couple times now, but we have this idea of actions. And what actions really are, instead of your view layer mutating the state as it sees fit, it needs to use a well-defined token or a descriptor that describes the type of state change that you want to happen. So we're going to swap out mutating the state directly with a token, an action, and it's going to be an object literal that just has a type property. And that type property is the way we describe how do we want state to change. So that's the first piece. And this is coming directly from Redux, but we're not actually using Redux itself yet. The next important piece we need is that reducer. And the reducer, remember, it's responsible for updating the state by taking an action and the current state. And so it's just a function that will take those 2 parameters and return a new value. So the reducer, the first argument will be whatever the state is. In this case, we're a counter app, so it's just a number. We're going to use default parameter values from ES6 just to say, here's the initial state. It's a nice convenience you would typically use in Redux applications. And then the second argument will be this action, this object literal that just describes the type of state change. And then we can use a switch statement, which we typically don't use a lot in JavaScript, but it actually lends itself really well for this type of application, because otherwise we would have lots of if-else checks. So what we're going to do is switch on the action type. We're interpreting which action is this. And so we start off, if it's increment, then I'm going to return state plus 1. That's how I'm going to update state. I'm going to create new state. If it's decrement, then I'll return state minus 1. Otherwise, I'm just going to return whatever was passed into me, because that's the reducer's way of saying, I don't know how to handle this. You're not using something that's a well-defined way of changing the state. And that's how we now start to focus on, we know how state changes. We just look at our reducer, we see what actions we handle, and we don't have to worry about view layer or controller or anything just mutating the state as we see fit, as it sees fit. So using this, it's just a function, so we could just update state by calling the reducer function. So if state initially is 0, I can call this reducer function with state and that action type of increment. It should give me back 1 because I'm going to do 0 plus 1. It's going to return new state, so I can grab a reference to that, and then I can pass it in again with another increment action. I get 2. So you see how this pattern is focusing our reducer to just take actions we know how to handle, and that's how we update state. And in fact, if we just tried some random action that we haven't made well-defined and the reducer doesn't handle it, it's just going to ignore it. So nothing's allowed to change state without the reducer knowing what kind of action it is. So now tying that back to our application and our view layer, the only thing we're missing is we have an action, we have a reducer, we need some way for the click to dispatch that action so we can actually update the state. So we could write this dispatch function, which is just dispatching an event, in this case an action. So it takes the action, it has a reference to that global state, and it has your reducer. So it just needs to call the reducer with whatever the existing state is and the action that was just dispatched, and that'll give it the new state. And then now that it knows state has changed, it can call render and it can update the DOM for you. And so now what we're doing is at the view layer, we've decoupled the event from the state change. Now the view layer, the event, it's just an event. When I click the button, it dispatches it, and then the dispatch function will handle updating the state and rendering. And we just implemented Redux. It's a little ad hoc, bespoke way for our counter app. This is literally all the pieces that really are going into Redux. We dispatch an action. Redux, in this case, if we're using it proper, it will handle updating the state and then notify you so you could render it out, the change. So that's really all there is to Redux. So now that we kind of got a grasp on how these pieces work together, let's actually bring in the real Redux library and see how easy it is just to take this code and swap out the real Redux. So the piece we're missing from Redux is called the Redux store. And the store is responsible for essentially doing what our ad hoc dispatch function was doing there. It will manage the state, it will use your reducer to update that state, and it'll notify you that state has changed so that your view layer can update appropriately. So in terms of code, from the Redux library, it has a createstore function. We can import that, and then I can use that to create an instance of a store. I'm going to give it my reducer as the first argument, and then I can give it optionally initial state. And it's optional because if you recall from the reducer function, we can use that default parameter value to set the initial state, and Redux can kind of figure out what your initial state is that way too. And then the store object you get back, it has a few methods on it, one of which is getState. So now instead of having the state out globally, it's contained within inside this Redux store. And to read that state, I can use this getState method. And that's important when we want to start rendering this to the DOM. But now let's just swap out what we have with what we wrote earlier. And the first thing is we can get rid of our ad hoc dispatch function and just swap over to the store dispatch method. And it's going to function the same way. It's going to dispatch that event to itself so that then it can use the reducer to update the state. The same thing we did earlier. And then when it comes to rendering, since we don't immediately know when an event was dispatched, the store will provide a subscribe method, which will let us know an action was dispatched and the state changed. And so inside of that, then this is our view layer, whether that's React, vanilla JavaScript, or whatever other framework. And so we can just use the getState method and update the DOM that way. So looking at it in a different way, if we want to look at it as a diagram, what is this overall flow? When we use the Redux store, it's kind of like a mediator. So above we have what the store is containing, your reducer and the current state. When we want to display that state initially, we can use that getState method. So our view layer, whatever that is, can pull out the current state and then update the DOM. Now when a user clicks on that increment button, remember that's going to dispatch that increment action. And we're using the store method for that. That means it's going to come up back to the store. It's going to pass that into your reducer function along with the current state. And then we have that switch statement. We see its increment. We return state plus 1. So now we return that. Redux knows about that. It's going to notify any subscribers. So we have that subscribe method at the view layer level. Then it can use getState and update the DOM. So that's really the overall flow. Everything's kind of flowing in one direction. So as opposed to MVC and two-way data bindings where communication can happen in both directions, we're forcing communication in one direction so that we can reason about it and understand it a lot more clearer. And we know state can only exist and change in one place. So that's really all you need to know for bare bones. What is Redux? How does it kind of work? But now let's start to add on to it and see some other patterns we can apply to just make it even more useful for building applications. So first thing, we can address a couple little problems that have cropped up by using Redux. First off, these actions, they're a little cumbersome to create. We always have to create this object literal with this type property, and so it's not as reusable to just recreate these objects everywhere. It's a lot more typing, essentially. So we'd like to fix that. Another problem is our view layer right now has a direct reference to the store. It'd be nice if we can kind of abstract that out so it doesn't have to know about the store, that implementation detail. So the first thing, and this is a very common thing in Redux applications, they have something called action creators. And it's a fancy term, but it's really just a function that creates these actions. It returns an action. So I can have an increment function and a decrement function that create those same actions that we were doing manually earlier. By convention, I prefer to use arrow functions here, just to make them really concise. So I have the arrow here, we have the no parameters in this case, and then we're going to have an implicit return here. If you're not familiar with arrow functions, you can implicitly return instead of using a return keyword. So I want to implicitly return this object, but to do that, I have to wrap it in parentheses. So these are just functions that return those actions that we had earlier. So that solves the first problem. We can swap out at the view layer here where we have our event listeners for click, and we can just dispatch those action creators. We invoke them, they return the action we expect, and that gets dispatched. It's still dispatching the action though. And so that just makes this a little more reusable and friendly. Now the other problem, we have this direct reference to the store. Is the next thing we'd like to fix. So the way we work around that is another concept in Redux is binding these action creators, essentially binding them to the store so they become a little smarter to where not only do they create the action, they also dispatch that action. So one way of doing that is we can manually create these ourselves. In a separate file where we create the store, we could pull in all of our action creators and we could export an object, actions, that contains each of those action creators. But each of them now is a closure that has a reference to store.dispatch. So you see here now, we create the action and we automatically dispatch it. Another way of doing that automatically with Redux is it does have a helper function for it called findActionCreators. But it quite literally does just what we saw earlier when we manually did this. We just provided the actions we want to bind in an object, and we provided the store.dispatch method, and it'll automatically bind the two together. But the nice thing now is we can return to whatever our view layer is, and now it doesn't need to know about that store per se. I can just give it this automatically bound action creator, and then when I click, it will know to create the action and dispatch it for me, and I don't have this reference to the store anymore. So it makes our code a little cleaner. So another big thing with Redux, as we've mentioned, is it's often associated with React. So I do want to highlight just some of the ways we can do Redux with React a lot cleaner than using those subscribe and get state methods directly. So the official way is this library called React Redux, and it's essentially a bridge between Redux and React, and it's going to abstract out some of that subscribe, get state methods that I mentioned earlier. So it's kind of look like this in the overall architecture. So state, we want to feed that into the view layer. React Redux is responsible for handling that part now, and then it'll provide everything that the React application that needs, and then the React application can dispatch the actions and then feed back in the whole unidirectional loop here. So zooming in on that a little, it looks kind of like this. So React Redux has two important components. One is called provider, and we'll see some code so we have more context on this, but what provider does is it provides the Redux store to your application, so yet you don't have to create a direct reference to it. Once you have that reference, there's another piece of React Redux called connect. It's another component. It's technically something we call a higher order component. But what it allows you to do is any React components in your application can use connect to expose the state and action creators, which typically you'll do the binding process to the dispatch method. And then they're going to, those components that use connect will receive it as props, so normal React props. And then those components, if they choose, they could pass those, the state and create action creators on down to their children as other props, so that the overall tree is getting access to the Redux store in a cleaner manner. So with code, let's say we have our counter app and we're going to implement it in React. So we have just a very simple React component here. Right now it's a static component. It has the buttons and it has the current counter value. And it's all static components, so it's not doing any state management. But we want to get Redux involved in the picture here. So we need to use those two components I mentioned earlier, provider and connect. So for the first one, the provider, it's quite literally a React component, and we pull it out of React Redux. But when we want to render our React application, as long as it has a reference to the store, the provider takes that as a prop, and then its child, in this case, my app container, which we'll define next, is going to have access to that store, and any of its children will have access to the store via the connect component that we'll see next as well. So it's just wrapping over your React application, essentially, and providing the store to it. Now here's where it gets a little more complex, and this is where we bring in the connect higher order component. And higher order component, that's a word used a lot in the React world. If you're not familiar with it, it's essentially a component or a function that creates a component. So we can import that from React Redux, and it's going to take two important arguments. It takes a few others, but most important here are these two called map state to props and map dispatch to props. And those sound really complex, but let's think about each in turn. So this map state to props, what that's saying is take the Redux store state and map it to props for a component. So in our counter app, we're just going to let that be a number. Our state is a number. It starts off as 0. So it's map state to props is just a function that takes that counter value as an argument, and then we need to return an object. We need to return an object because React props are objects. So we're just going to map the counter value to an object that has a counter property in it, and that'll be available to the React component that we had earlier. Then we have this map dispatch to props. So first with map state, we expose state. With map dispatch, we can expose action creators. The map dispatch will receive the dispatch method from the store, and then we can do that binding process here. And so I can take my increment action and my decrement action, and I can bind them to the store, and we'll rename them on increment and on decrement so they have a more callbacky sounding terminology. So when I pass both those in, connect's a special function actually is going to return a new function, which helps it be useful if you're doing anything with Babel and decorators with classes. But we pass in our other components. So the myApp component, recall that's the component that has the buttons and the counter value in it currently. So what we've done here is this container that we've created is what we call a smart component, in that it knows how to wire everything up to Redux. So it does all that logic, and it's going to expose these things to the myApp component, which we'll look at next. And this is what we had earlier, but we call it a dumb component. It doesn't know about Redux. It doesn't know about these implementation details. All it knows is it receives props, and those props contain those things that we exposed from the Redux store just a moment ago. So if we take in the current counter value, that's going to come from the store state via that map state to props function that we had earlier with connect. Similarly, with the action creators, those will come in from map dispatch props. Remember, we bound them to on increment and on decrement. So we just have this separation of concerns where this container, or the smart component, it knows how to interact with the Redux store, get out the stuff it needs, and then it passes those to this other component where it's a dumb component, and it doesn't know about those implementation details. So that way, if you ever wanted to change how myApp container works, you can change it without having to touch the myApp component that really displays and has the interactive elements for your application. So that's just a brief overview of how we work with React and Redux. But let's start looking at Redux again alone and seeing some other important patterns that crop up with it. So far we've been talking about state, and we've only been using a number for that simple counter app. But more than likely in your applications, you're going to have more complex object state instead of just a simple number. And so we need to think about how do we do state like that in Redux, because the reducer needs to return a new instance of the state, but we only want to change certain properties of that state. We want to keep other properties the same. So we want to do that in a mutable fashion. So let's say we have another application. We'll persist our counter example. And let's say it's just an application for configuring a car. We're going to change the color of a car, for example. And maybe the counter is it's keeping count of how many cars we've configured. So we have the counter property, and then we have this car property, and it's going to have the initial color set to red. And we want to manage this state with Redux. So we'll introduce our action creators that we talked about earlier. We already saw increment and decrement. We'll introduce a change color action creator now, and that's going to be responsible for changing the color of that car. Now these action creators, they don't have to be parameterless. You can actually give them parameters. And that way they're configurable. So in this case, the change color, not only is it going to signal I want to change the color of the car in my state, but I can also give it a payload that says, here's the color I want to change it to. And so this payload property is pretty standard in Redux for when you want to provide additional parameters in your actions. So the reducer then, will again, set the initial state with this default parameter value. And then now, as we take in these actions with the switch statement, we need to return an object that has the same shape. It has a counter property and it has a car property. But we only want to change certain pieces of it. So one way of approaching this is to use the future feature in JavaScript called the object rest spread property. And what it essentially does is it takes the original state there and it sort of spreads out all the existing properties in it into a new object. And then whatever's to the right is anything we want to update or change. In this case, we want to keep the existing car value in the state, but we want to update the counter value. But we got to make sure we keep the overall state. Now, if you're a little averse to using future features in JavaScript like this, you could use something like low-as assign method, or even object.assign, which came in ES6 and is standard JavaScript. So there's different ways of doing this if you don't want to use the spread operator. But the main idea is we want to persist the shape and only change certain pieces of the object. So we can do the same thing with decrement and with change color. Notice this time we're spreading the state, but we're persisting the counter value, but we're only changing the color of the car. And we're using that action payload property that we used in our action creator. So if we played with this a little and we subscribe to the store, we want to dispatch these things. When we dispatch increment, Notice that the counter value is going to go from 0 to 1, but the car is going to persist because we use that object spread property. Same thing when we dispatch changing the color. The counter property will stay the same, but then we're only going to change the color of the car. So this is how you're going to typically approach doing object state with Redux. But this does introduce an interesting problem. What happens if you're in a very large application now, your state object is really starting to grow? What does that say is going to happen to your reducer? Well, it's going to start to get many, many lines of code, and it's actually going to become harder to understand, which is going against what we really want to get out of Redux. But there's an approach we can take to solve this and still keep our application maintainable. So another thing that we can do with Redux is we can introduce reducer composition. And that's just a fancy way of saying we're going to have multiple reducers. And even though that is technically spreading out the state, so to speak, we're still going to keep it consolidated by having one root reducer that's responsible for managing all of them. So it's just like a main reducer kind of coordinating other reducers. So it would look something like this. We would have, for our application, we'd have a counter reducer that manages the value of that counter. And then we'd have a car reducer, which manages the state of the car, which is currently just changing the color of it. But then we'd have above them a root reducer that is responsible for coordinating both of them. And we're still managing the same object state. So the counter reducer, it would look like what we saw earlier with the original reducer. It just has the state equal to 0, and then we have increment, decrement, so on and so forth with this one. For the car reducer, we're going to have our initial state set to color red, because that's what the initial car was. And then we get the change color action. It's an object, so we could also use object spread here. That way, if we want to introduce future properties to the car, we could, and manage those with actions as well. But we have two separate reducers. To tie them together, we just need a function that calls both of them. So this root reducer is going to sit at the top, and that's the reducer you'll give to the Redux store. So there's still one place where state changes. In this case, we'll let its initial state be an empty object, which is fine because each of those individual reducers know how to create their own initial state. And so every time an action comes in, we'll call the counter reducer. We'll give it the current state.counter value with that action. Additionally, we'll do the same thing with the car reducer, and each of those is going to know how to update the appropriate piece of that object separately from one another, and that's going to help reduce how many lines of code we have and hopefully make this more modular and maintainable. Now, not to be outdone, Redux does have its own method for doing this too, but it's quite literally what we just did manually. This combine reducers function essentially does the same thing. It's going to create a function that wraps over the other reducers. And every time actions come in, it'll just call each of those individual reducers with their own state and let them update it as they see fit. So this is nice, but one word of caution and something we need to be careful to think about. As the application grows in number of reducers, we also have the potential for multiple function calls. Remember this root reducer, it's going to just pass on the action to every other reducer. It has no way of knowing if a particular action is only really meant for one particular reducer. So as an action comes in, that's going to get passed along to every other reducer. So the main word of caution here is, if you're going to use Redux to manage your state and you have this large application tree, I would make sure, double check your performance. I wouldn't immediately say don't use reducer composition. But be mindful of that and think about that. If you are running performance issues, it could be possible that you just have multiple function calls happening because of this reducer composition. So one other thing as we move on is we've been talking about state a lot and just very simple applications. But what happens when we need to eventually start interacting with APIs in a Redux controlled application? We really haven't talked about any affordance for that yet. So the typical way we approach it is by using another piece of the Redux architecture called middleware. The middleware are responsible for enhancing Redux applications to do other things besides just managing state. So examples of these is we could do logging in our applications, we could do debugging. As I mentioned, we'll do API interaction to make API calls, or even creating our own custom actions that are not just objects with a type property. So middleware kind of sit right here in the Redux Architecture. They're going to sit between the actions and the reducer, and they can essentially intercept actions as they are dispatched. And they can choose to handle them in their own way, or they can pass them on to the reducer. And you can have multiple middleware as well, so sort of a chain of middleware intercepting these actions. So one example of these would be a logging middleware, where we can log out an action that's dispatched and how state changed. Now, middleware definitely very confusing at first. They have 3 parameters, but they use this curried definition, and if you're not familiar with curried functions, that's fine. Mainly the convention here is we're going to separate these arguments with arrows, because it's essentially going to take one argument at a time and return a new function. But these 3 arguments, the first one is API, which is really just the store's API, like the dispatch method, get state method, etc. Next will be a reference to whatever the next middleware is in the chain if you have multiple middlewares. Otherwise, if you're the last middleware, it'll essentially pass it on to the reducer. And then finally, the action is just whatever action was currently dispatched. So here I can log out the dispatched action. I can pass it on to any other middleware and accept their result in case I need to return it. And then once I've called next, I know that it's probably hit the reducer now. So I can then call API get state to log out the state. And just to be a good citizen, I'll return whatever that result was in case another middleware depended upon that. So to bring that into the store, we're going to use an apply middleware function. And it's essentially just going to be another argument to create store. We provide it the reducer like before, and then we call apply middleware, and we can pass in as many middleware as we need, and that'll be another argument. But Redux will know to basically wire up these middleware and ensure that they see the action before the reducer does. So when I dispatch increment, I'll get printed out to the console that I dispatched that type increment and that the state updated with the counter going to 1. Same thing when I dispatch changing the color to green. I'll get the type of the action, and then I'll get the state change where the car color went to green. But now let's really take this middleware concept. That's just kind of an introduction to help you understand what are middleware, how do they work, and let's really use it for something more practical like doing API calls. So let's say we have some state like this for an application. We have an array of users, and we have this isFetching flag. We just want to fetch some users from an API. So our reducer, we would take that state, the initial state that I showed you in actions, and we'll have a couple of actions. Request users and receive users. For request users, that is the signal for the reducer to know that we're initiating the API request. So we'll flip that isFetching flag to true, and maybe in our view layer we'll have a spinner display whenever that value is true. When the API response comes back, we can use a receive users action. We'll flip the isFetching back to false, and then we'll accept the users as an action payload. So that's just how we're going to manage the state side of things. We'll still see how we make the API call in a moment. So our action creator is pretty similar to what we've been seeing now. Request users just returns request users type, receive users takes users as a parameter and returns that. But to make that API call, we can introduce another middleware called the Thunk middleware. And this actually is a library called Redux Thunk, but its implementation is pretty much just those lines of code. So you could implement it yourself. But so far, all of these actions have been object literals. But we could use this way to create a custom action that is a function. So if it's a function, when this gets dispatched, we're going to know this function wants to make an API call. And so I'm going to provide it a dispatch method so that it can make the API call. It can also signal those actions like request users, receive users, so that the reducer can also update the view layer with the spinner and then eventually receive the users. But we're going to return immediately. We're not going to call next, because if we did, Redux would say, you normally can't dispatch functions. I'm expecting an object. And that's where we're intercepting it here and doing our own logic for API calls. Otherwise, if it's not a function, then we'll just let the other middleware and reducers handle it as normal. But the actual thing we're going to dispatch and where we're going to make the API call is going to look something like this. We have a fetch users function that returns another function. But this maps kind of back to our action creators and actions. The fetch users you can think of as an action creator. And that's what we're going to dispatch when we invoke it. And instead of the action being an object, remember it's going to be a function. And so we'll return a function. That function is going to take the dispatch method so that it can do a little more business logic here. So because it has access to dispatch, it can, before it makes the API call, it can signal to Redux that I'm making the API request, you can flip the isFetching flag to true, the view layer can display the spinner, and so on. Then we're going to make an API request, and when that resolves, we can dispatch receiving the users, because that data is going to come back to us. And now we can tie this in nicely to Redux by using this Redux Thunk middleware. Now there are a few other approaches we can take to writing asynchronous code in Redux, and I'm just going to highlight them, not diving into any in particular, but this would be appropriate if, say, you have more complex business logic or asynchronous flows that Thunk middleware makes it a little more cumbersome to do. And these will still be middleware based like we saw with this Thunk middleware. But some options are Redux Saga, which is one of my personal favorites, and it uses ES6 generator functions and allows you to write a lot of your asynchronous code in a more synchronous manner, and allows you to model things like parallel requests and background tasks. It's really useful. Another option is Redux Observable, and if you're using RxJS Observable, this is perfect because that's one of its dependencies, but it allows you to model a lot of your asynchronous flows in Redux applications with observables. And then another alternative is Redux Logic, which does a lot of the same things that Redux Saga and Observable do, but it's just more general purpose. It can work with promises, it can work with observables itself too. So the final piece I just want to cover, if we're talking about all these facets of Redux, is how do we talk about testing? That's an important thing that we overlook sometimes. So one of the nice things about Redux is that testing is actually very easy. If we think about our reducer and how we need to test that, because that's a big one, it handles our state changes. Well, it's just a pure function. It returns values based on its arguments. So that's just unit tests. That's easy to test. I can call my reducer with the state in a certain action, and I expect to get back a certain value. If I call it with increment, and I expect the counter, I expect it to go to 1. Same thing with the car. So it's really easy to test your reducer. Now, for action creators, you can test them, but you're going to capture a lot of that in your reducer tests anyway, so it's not really necessary, but again, you could test them. They're very easy to test because it's, again, just unit tests. However, you should definitely test the asynchronous action creators like the Thunk middleware, because there's a lot more business logic going on there that you want to make sure you capture. So the approach I like to do is do a unit test, but do it with a lot of test doubles. And the main reason for that is you want to make sure you are testing the unit. So you want to mock out all of your dependencies as much as possible, whether that's the API call, that is even the dispatch function. And then we can test, if we use a spy for dispatch, that I can verify that this Thunk, when it made an HTTP request, that it dispatched certain actions, like it requested the users and eventually it received the users. So unit tests are really nice here, especially with test doubles. And then finally, I think integration tests are really nice on top of your unit tests. And the main thing for that is just a sanity check to make sure that all these pieces, even though they're individually tested, that when they come together, they meet your expectations. And so with an integration test, the idea is because we want to really test everything, is I'm going to create a real store. Now the only thing I will mock out is the HTTP, because I'm not too concerned with that. I'm just going to assume that I'll get back a good response. I could write tests for if there are bad responses as well. But I'm mainly concerned with, is the Redux store operating properly? So then I can dispatch, and I can create a subject, which is whatever the current state is, and then I can just inspect the state to make sure everything is working properly. And so that's how I like to approach testing with Redux. And as we close, just some resources. These slides are available online as well, but if you're interested in diving more into Redux, learning more, following tutorials, these are some good resources for getting up to speed. And thank you all so much for joining me. I appreciate your attention. And there's a link to the slides. Thank you.